Today I will be talking about information retrieval. In the general setting, like in the open domain setting, I will talk about what it is, the information retrieval. I'll also talk about current like models and approaches to information retrieval, and also then I will talk about the information retrieval in Polish language and what we have done so far as a community. And yeah, I guess that's the main things that I will talk about today. So here is agenda. First I will do the introduction, then I will talk about the models and the metrics, and then I will go to the resources available in general, but mostly for the Polish language. That's where we did our contribution, and I will finish with some future work and summary. So the first thing is what actually is the information retrieval. So some of you may heard about it and already know exactly what it is, but the main idea is that we have a document collection and we want to somehow search it with some query. So we want to access some information. And usually it is in a way that we have stored like large amount of text documents or passages, like few millions or something like that. Then we have a query or a question in natural language, and we want to retrieve the documents or passages that are relevant for a given query. And here is the picture that I've took from sentence transformers. So it's usually like that we can have some retriever that's get some top documents or passages from the document collection, and afterwards we can use some other models, other techniques that are re-ranking the retrieved documents to get like the most relevant hits. So yeah, so basically we have document collection. We are trying to get the most relevant documents out of it, and as a result, give like the documents that are relevant to the user or to some other model, and or somehow use it. So why it is actually useful and important, why we should care about information retrieval. Mostly because it's like the crucial component of the question answering system when we are want to give the model the access to the document collection with certain knowledge. So that's very important. Then we want to have this proper retrieval and answer based on some knowledge in some domain. For example, you'd like to have like medical question answering system, then you'd have like the medical database, and the model will be able to answer with the medical knowledge at hand. And also it kind of prevents the hallucinations, because we can have a model that already is able to answer the medical questions, but it may be providing some false facts, and by providing the correct facts to the model when the model is answering, we may like it's a kind of a remedy for the hallucination problem. And also it keeps the information up to date, because we can easily update the information in the document collection. And also it can be used in many different other areas like product search, to research, or some other kind of search, or when try to find something relevant over a large collection. And now I will go briefly through some methods and some papers that are currently kind of applied in information retrieval. So first is like the lexical retrieval. It's mostly like BM25. So this is the retrieval based on the lexical properties of the language. Then we have dense retrieval. So in this case, we are already using some kind of models like transformer models, and those models are used to encode the text in a proper embedding, so in a proper vector that then can be used to retrieve proper documents. And there's also like sparse retrieval. So there are also like neural network models like transformer models that can be used in a way that the documents are encoded in the token space. So it's kind of sparse embedding because we get the representation of the passage or the document in this space of the token. So it's kind of sparse representation, but not from the lexical point, but from the neural network. I will talk a little bit more about those approaches later. And also there is a re-ranking. So re-ranking is a kind of additional step in information retrieval. When after the retrieving, let's say 10 or 100 relevant passages or documents, then we are using some like, let's say, better. I mean, better is not the right word, but another model that would provide the better ranking of the passage and queries, because we are putting both of them at the same time to the model, so it's able to kind of look deeper into the query and the passage. So those are the methods. So as I said before, PM25 is the kind of lexical. So you're looking at the words basically, or lemmas in the text, and we have some kind of scoring function, and the implementation is already in Elasticsearch. And it's really widely used in information retrieval because it's actually pretty good baseline for most of the problems. It works pretty well, pretty fast. We can index our documents like even large scale without any issues, and it works pretty well because usually when there is like some lexical overlap between the passage and the document, then like this PM25 is able to retrieve the proper documents. So it's basically lexical approach. It's a very strong baseline, and it was really hard to beat for quite a long time when it comes to like this information retrieval in this kind of open domain setting, when the domain is not properly defined and we have like open domain. Then the PM25 was really a strong baseline. But right now we have transformer models like BERT that were already like pre-trained on large corpuses, and those models get some kind of we would want them to have like some higher understanding of the language, and they're able to kind of also understand the senses of the words in the text. So those models are used right now as also like the encoders of the text. So we can get a text representation from those models, and we would like those representations to be relevant for the information retrieval task. And one of the first approaches to that was SentenceBird, and there's a whole library. SentenceBird library is quite popular, and the idea is that we have like BERT model or some other transformer model, and those are used to produce some kind of representation. And when we have two representations of like one sentence and another, then we can compare it with similarity, and it's usually a consigned similarity or a dot product. And also like that there's pooling. So when we get the representation from the transformer model, we're usually doing some pooling to get like one vector, and usually it's CLS pooling or mean pooling. And yeah, so we can train those networks on the pairs, so that the representation of query and passage that are relevant to each other is high, the similarity is high, and when they're not relevant, the similarity is low. And so there were different kind of approaches to those encoders, because we can have like the same encoder for query and the same encoder for the passage. So for the document collection, we are encoding them with the same model, but also we can have like two models. So one model is basically trained only to encode query, and the other to encode documents. And there are different approaches to that, just so you know that there are many like kind of combination of those, how to make it work better or more efficient. And why those behavior control architectures are useful and why they are fast, it's because when we have embeddings, so those one vectors that represent, for example, those documents, then we can store them in vector databases, and there are quite a lot of them, and they're pretty fast. So they enable us to do this approximate search very fast through like the large collection of vectors. And that's why it's really fast, because when we have like compute the whole collection, for the whole collection we compute the vectors, the representations, then we can store it in this database. And if the encoder is not changing and there are like no more documents, we can just keep it, and then we can just compute the representation of the query and get the results. And it's really fast, and we don't have to update anything. And the most kind of famous approaches to dense retrievers was dense passage retriever. That was the network that was trained. There were two encoders, one for passage and one for queries, and it was trained with like in-batch negative samples, and also the batch size was quite high. So that was a very popular approach, dense passage retriever. It was kind of famous, and also I linked here multilingual pre-trained model if someone would like to try it for Polish language. So yeah, I'm just mentioning those approaches and putting here a links to the multilingual version that also work for Polish language. And right now there's also E5 retriever model. So this is right now the best model for Polish language that was trained on multilingual data. And here's also the Hugging Face link to that model. As we can see, they got like really high batch for pre-training task, and pre-training task was done on the corpus they made by themselves by filtering a large amount of queries and passages. And they added some task prefix, but the main training is not very different, and they fine-tuned it on the data set that is called MS Marco. I will talk about later. And yeah, this model is right now the best for the Polish language. And also want to mention that there are some unsupervised pre-training. So there are unsupervised pre-training methods for the dense retrievers. So it's not always that you need query and passage pair to train it. But people were thinking about different kind of methods to do the data augmentation for this task. And usually it's some kind of cropping. So we get some kind of document text and we try to get a part of it as a query and the rest of it as a document. So here I would like to emphasize the inverse clause task. So the query is basically generated by extracting a part of the document, and that's how we get like some kind of pseudo training pair with query and relevant passage. And also there's a model that was trained with a lot of those negative samples, and it's called mcontriver. It's also works really well on Polish language. And also a few words about this sparse retrieval, because that's also some kind of approach that's hopefully will be also relevant for Polish language. The idea behind the sparse retrieval is that we are reusing the matrix that was used when the transformer model was trained, and we are trying to put the dense representation using this matrix to the space of the tokens. So we're trying to use this MLM matrix that was used in the pre-training to get the representation over the vocabulary length. And there were the most kind of, I would say, famous because there are certain papers about it, approaches is Splade. And there were like few versions of that already. When basically the representation of the passage and the query is put into this very high dimensional space of length, like 30K, depending on the tokens vocabulary. And there are also other approaches that kind of reused this idea and try to kind of maybe aggregate it as agretriever. And this approach actually tries to aggregate this whole representation over the tokens to some small representation with aggregation mechanism, and also reuse a little bit of the CLS token representation. So there are many approaches like that, but we can try to use like those sparse retrievals and put it into this large space, and I believe this approach will be also relevant in the future. Also want to mention that when training dense retrievers, there is many papers that state about the importance of hard negative samples. So for the most data sets, what we get is the relevant query and the passage pair, but we don't have like the negative examples, but we get like kind of very large corpus of documents. So to train the model and make it kind of work better and better distinguish the relevant passages from not relevant, then there are many things when they're trying to mine the hard negative samples. So if we have some model and it's getting high scores on some negative samples, then we can reuse them during the training process and provide it as hard negative samples. So we'll deliberately train the model to distinguish between those true positive passage and the hard negative, so it learns the difference. And right now going to the re-ranking. So the re-ranking process is, as you can see in the first A picture. So basically retriever is when you're able to compute the representation of the passages and store it somewhere, and they're kind of the representation of the query and the documents are computed apart from each other. But when it comes to re-ranking, we are putting the query and document at the same time to the model. So that's the issue, is that we cannot pre-compute anything. So if we would like to use kind of re-ranker to re-rank maybe the large collection, like 1 million documents, then you have to rerun it like 1 million times for every query. So we cannot pre-compute anything. But this approach is very good when we just retrieve, let's say, top 100 documents with the retriever or with like some BM25 algorithm, and then we do the re-ranking because when the model got access to query and document, it works so way better. And yeah, so there are some common approaches. One is called like monobird, and it's currently applied to like BERT-like models. We are basically putting the query and the text together, and in the end we are doing the classification of the CLS token to get the answer whether the query and text are relevant or not. So it's basically the classification task for ranking. And also we can do that with sequence-to-sequence models. So for example, the model like D5, we can add some tokens that are true or false, and then we ask the model to return the true token or the false token when the document is relevant or when it's not. And this way we are training kind of the classificator, binary classificator, with sequence-to-sequence model. And there are also other approaches that we can do the same with like kind of the one token, one extra token, or we can skip the decoder part completely. So I'm just telling it so you know that there were also other approaches, but the difference in results weren't that big. So I'm not sure what's really better approach to use additional tokens or not, but just so you know. And the metrics, common metrics is recall. So how many relevant documents from the collection were classified at certain ranking. So you're calculating the recall at let's say 100 or 1000. So that's one metric. Another metric is MRR. So this metric measures the rank relevance. And another metric is normalized cumulative discount gain. So this is another metric that takes into the account the ranking of the relevant passage that was returned in the end. Okay, and now let's go to the part about the resources and datasets. So in English language, there were a lot of different datasets and resources. The most popular resource for information retrieval in English language is MS Marco. So it's a large-scale dataset. It goes like 1 million, 500,000 queries, and the documents is like maybe 8 million, I guess. So it's really a good resource with some kind of, we would say, general maybe questions, because they're all kind of general and in like kind of open domain. So this resource is pretty good for training the information retrieval models. And then we also have got a pure benchmark. So this benchmark, as you can see in the picture below, it's got some large amount of data sets from different domains. And the idea behind this benchmark is that the model is trained on MS Marco, and then it's evaluated on other data sets. So this way, it's possible to test whether the model was able to generalize to the open domain. So it's not fit to the one certain domain, but it's also able to perform well on different data sets from different domains. And there are other resources for English language. There are also multilingual data sets. So MS Marco was translated to 13 languages. And also there were like data sets with also many different languages to test the dense retrieval. But the thing is that there were no Polish language included in those large data sets. So that's why we decided that we need to have also something in Polish language. The main goal was to add some large-scale resources for Polish information retrieval, and we are working on this BIR-PL benchmark. So the idea was that, okay, let's translate all the data sets from the original BIR benchmark, try to train models on those, evaluate them, and check if the resource is working properly. So the models are tested and we can see the difference whether the models are working or not. And then if we can use them in some other information retrieval tasks. And during that time, it was I guess that the work in this area was like mostly done during the last year. So there were like this BIR benchmark when there are resources for Polish language, but there also is Małpka right now. So just to mention, it's also large-scale resource available right now with like nearly 400,000 question passages. They're from different sources. Some are generated, some are taken from another available single data sets, but it's also a kind of large data set. And also during this time, there was O-level challenge. Passage retrieval, when there were like 3 different data sets, and the main challenge was to just get the best results possible on those 3 data sets. And they've got also like 3 different domains. So there's like Wikipedia, Wikipedia. So the questions about Wikipedia, about some general knowledge. There's also Allegro, FAQ, so the questions about like customer service, and there are also legal questions, so the question about some legal stuff. And here I also listed the publications, so you can check them out later. Okay, so about the BIR-PL benchmark. So the idea behind this benchmark is to test the models in zero-shot setting on a large amount of different data sets. And there are many of them, but the main is the MS Marco. So it's large-scale Bing questions, and it's used for training. There's also like a small set of for development and testing. There's natural questions, so it was actually questions from Google search, and also it's based on Wikipedia articles. It's also kind of the general data set, but there are also like data sets like NF Corpus, which is the data sets about some nutrition facts, and also like there is Arguana, which is like completely different because it's the dataset that focuses on retrieving counter arguments. So we get argument, and then the kind of the answer we're looking for is counter argument. And there are others. So here is the list. also with the average length of queries and average length of documents. So you can see that there are quite a lot of them, and they're different. Basically, like those Steve facts, it's like the last one is the kind of fact verification data set, and it's kind of small compared to others because the test queries is just 300 and the corpus size is really small, like 5,000. So it's kind of the smaller data set in the whole mix. There's like Quora data set, so it's a little bit different data set because it's basically the data set of duplicate question pairs. So it's the main goal of the data set is that we have a question and we have the same question but asked in different way. So it's a little bit different from the retrieval part when we are trying to find with the given query or trying to find the proper document. And there are others. We can see also like the corpus sizes are also differ a lot. Like for MS Marco, it's nearly 9 million documents in the corpus. But for others, it's maybe like like for example, VQA, it's just 57K. Yeah, so different domains, different corpus sizes, and also like different document lengths. So it's kind of the setting that we are having here. So it's kind of zero shot with different domains and also kind of different characteristics of the data sets. And what we tested in BEER benchmark is we compared different models that we trained on MS Marco. So the baseline was BM25, so the lexical one. The other thing we tried was to train a retriever in an unsupervised manner with inverse closed task, which are briefly described before. And also we tried different re-rankers. So one was Herbert-based re-ranker, and other was PLT5-based re-ranker. So one was sequence to sequence and one not. And other thing, we tried late interaction re-ranker based on Herbert Waller. So the late interaction is when the interaction is at the last layer of the model. So it's not goes fully from the model, but only on the last layer. There's kind of the interaction and looking for the similarities between the query and document. So those are things that we tried. And first, when it comes to results, we saw that the results from BM25 weren't that good. It was actually very similar to like the German, Russian, Chinese, even a bit lower. Yeah, but on the same level, I would say. So the BM25 wasn't working that well. And one thing to mention is that we are using the Stemple Polish analysis plugin for Elasticsearch, but we haven't checked morphologic Polish lemmatizer, which might be a little bit better for BM25 in Polish language. So that's something worth checking. Because yeah, the results are not really good compared to other languages, especially for English. I mean, we expected that they would be worse, but hopefully maybe with this other lemmatizer, that they would be a little bit better. But this is the baseline. And now when it comes to results, at the very top, we have the baseline result, and the metric is this normalized discounted cumulative gain here at 10. because most of the models starting from M-mini-LM, Herbert, T5 and Colbert are re-rankers. So what they're getting the top 100 results from PM25 and they're re-ranked. And we are checking if the ranking order is better. And also there's this ICT, which was the unsupervised learning, and the results aren't really good. So we can see that the solely unsupervised learning is not as good as in some large-scale publications. And also we also compared to LAPSE, which is a model doing pretty well with sentence similarity. And there's also multilingual model, M-mini-LM, which was trained on English MS Marco, but it's a multilingual model, so it also worked pretty well for Polish language. So we also put that into the mix to have a comparison between like our models and the multilingual one. Yeah, and the interesting thing is that from the results, when we were analyzing it, it seemed to me that the T5 based model are understanding the task very well. I guess there's a question, if I see correctly, I'm not sure.
Yeah, yes, may I interrupt you just for a moment, because you indicated T5, it's not MT5.
Sorry, so it's actually PLT5. So it's the Polish. Yeah, so sorry, there should be a PLT5 based model. Yes.
Thanks.
So it's the Polish version of T5 model.
Thank you.
Yeah, so here we trained the Polish-based models like PLT5 from Allegro, and yeah, we tested its performance. So from what I saw and looking at the kind of results, it seemed for me that this PLT5 model was able to kind of understand the task pretty well, and it got like the best scores. I mean, they were quite kind of similar for Herbert-based large and PLT5 large model. But when looking at the Arguana, for example, so Arguana task was to retrieve the kind of counter arguments, and we can see that the scores for PLT5 large model are really low. And I believe it's because the task is a little bit different in this case than from the regular MS Marco task, when we are having query and trying to find the relevant passage with answer to that query. So in Arguana, for example, when we get like the argument and we are trying to retrieve counter arguments, it's not kind of intuitive to the model, and the model understands the semantics. Actually got the lower scores than other models. So kind of based on these results, I think that the T5 large model actually understands the semantics of the queries and the passages better. And also, yeah, and also it seemed like this model was performing, yeah, the best. The scores are really similar, but based on these results, that's my intuition. Also, what we did, we tested those models, those ranker models, on the POLEVAL. So we took those 3 different data sets from POLEVAL competition, and we tested them, and we tested our models on them. And in this comparison, it seems like Herbert-based large works the best. I mean, the results are pretty close, but yeah, the Herbert base, Herbert large was the best one from the evaluation point here. So based on those results, we all can see that there's an improvement over the baseline, like is the BM25. So the ranked results are way better. And yes, so that means the pre-training on this MS Marco really worked. That was one thing that we are trying to figure out, whether it's really worked or the translation of the MS Marco and other data sets made it kind of not really feasible for training, because there is also mistakes when it comes to translation. But it seemed that the quality of the translation was good enough, and we did some tests when it comes to the translation. So we asked linguists for the evaluation, and the kind of the raw results weren't that good, maybe like 60% of correctly translated passages and queries, but when it comes to kind of the semantics, because here we need kind of the semantic understanding, and the semantic similarity should be relevant, then the correct translation was at about 80–85%. So that was way better. So for the task, it was good enough. Also, the details about the training are in the paper, because I also believe that the models could be trained better, because, for example, T5 large model was trained only with 600K examples, and compared to like mini-LM was trained, or I believe 40 million examples. So there's a large difference between the computation there, but we wanted to just train it for kind of one day, and not to like kind of compute it longer. So there were trained about one day when it comes to T5 large and Herbert base large. Also, it's worth to mention that right now we have Polish information retrieval benchmark. So it's work of Marek Kozłowski and Sławomir Damlas, and they're kind of gathered the resources that we have right now, like Polevar datasets, BIR.pl and Małpka and some others, to benchmark the currently available retrieval models for Polish language. And yes, so that's worth mentioning that right now, as a whole community, we're having a lot of data sets. We are getting this benchmark, so we're able to check which models are the best right now for our language. Also, there is this massive text embedding benchmark, and the kind of really good fact about it is that there is English, Chinese, and also Polish language right now, because we've added this BIR.pl benchmark to this massive text embedding benchmark. So also there are models evaluated there. And if you have like some data sets probably connected to information retrieval or semantic similarity, it's also possible probably to add there. So we as a Polish community with our resources are also visible outside. So hopefully the next multilingual models will be also trained on them and work a little bit better on Polish language. And yeah, so for the future work, I believe that we should also test many different sparse retrieval models, like Spade for Polish language. I haven't seen it done yet. Also, there's many knowledge distillation approaches. So when we have these re-ranker models that doing the classification, and it takes the both query and passage together, we can do the distillation of the knowledge to retriever, and there are different losses used to do that, like margin mean square error, and this is the base in the transformers, but there are also others like Cal divergence or rank loss that can be applied for that. I'm not sure which is better, but yeah, I think that's also the way to improve our retrievers. And also, I haven't seen like the fully trained dense retriever right now on all available resources for Polish language, but I know that people are working on it. So that's the future work. And yeah, and the summary is that kind of we as a community here in in Poland, we gathered a lot of resources for Polish language for information retrieval. And yeah, so right now we are able to progress in this area a lot faster, because the data sets are very important right now when it comes to training. And yeah, I believe there's still a lot of work to be done. We have to improve like all those 3 ranker models, because I think that they can work way better and get like better retrievers. And yeah, and also there are so you know, there are multilingual models that also perform pretty good on the Polish data and are available right now, mostly trained by like Meta or Microsoft, but they're out there. Okay, so thank you for your attention. Also, the thing is that the models are available on Hugging Face at Clarin KNext. There are models like this PLT5 pre-trained on MS Marco and Herbert. Also, the PurePL datasets are there. So like MS Marco and others, they're available at Clarin KNext Hugging Face. And yeah, thank you for your attention.